Alright, welcome back. In this section, we shall put together all the little pieces that we have collected into a complete neural network. Hi, my name is Dimash Shafara and I'm a data scientist at Raising the Village, an instructor at Data Idea, and I set out how people become data scientists by covering data science concepts in a simple and intuitive way. So if that is interesting, just make sure to click some subscribe or follow or something like button so that you keep getting such information that I am creating. Okay, so the first thing that we shall do is we shall install Data Idea, and this is a package that I have built to help people practicing machine learning. For this section, we shall only use it to load our data set. So let's just install that, and then we can import Data Idea as DI. Okay, and then we can load our data set. So let's just do that. We can do that by doing di dot load dataset, and then we can pass in the name of the dataset that we want to load. I have a dataset called Boston that I put inside here, so we can load it like this, and then we can store that maybe in a variable like this. Okay, so let's just run this and then we look at the Boston dataset. So let's just look at the top part maybe. Alright, so this is our dataset and our target is this, which is the median value of owner occupied homes. And then there's a bunch of other features here that we are looking at. Um, Maybe L-stat, for example, is the percentage lower status of the population. We have B, which is the proportion of blacks. Apparently, being a black was something to consider. Being with blacks was something to consider when they were collecting this information. And then a few other things. Tax is the full value property tax, and crime is the per capita crime rate by town, and more about this data will be linked in the description so that you can check out. For here we just want to focus on building our deep neural network. All right, so the next thing we want to do is we want to set up our feature set X, and we also want to set up our target feature, okay, Y. So let's just do that. Now we can get X, which is all other values other than the target column. So we can just do dataset dot drop. So by dropping the median value, which is our target, it ensures that we remain with only our features. Okay, so we can set the axis to 1, meaning that we are dropping a column, and then we can set our target to be the median value. So we can just do a data set, and then from that we pick out the median value. So somewhere here, oh, it's here. All right, so we can just run this. By this you can see that we have the feature set right here. Okay, and then we have also our target. It's pretty simple, straightforward like that. Okay, uh, here's one thing. Deep neural networks tend to perform better when we do some transformation to our data. So we shall transform our values, these values, to have a mean 0 and the standard deviation of 1, and using what we call the standard scalar. So let's just create our scalar function. So we shall say scalar is equals to standard scalar, okay, like this. And we can set our X now to be the standardized set. So we can say scalar dot fit transform X. Now we see some squiggle at under standard scalar. It's because we haven't imported it. So let's just come up here and we import. So we shall say from sklearn dot preprocessing import standard scalar. Okay, just like that. Okay, Now let's come down here and we run this. Okay. Now if we get a look at our X set, we shall see that we have now an array of standardized values. Okay. Now the next thing that we shall do is we want to convert these values to tensors, because PyTorch and deep learning uses tensors a lot whenever they are training models. This is because of a reason I mentioned earlier on, that tensors can be accelerated. Okay, so let's just convert this by saying now x is equals to torch.tensor. Instead, actually, let's first import torch. So I'll come up here and I'll import from torch, I'll import tensor. So from torch, import tensor, like that. And then we can do instead tensor, and then we can set up x, and then we can set the data type as float as float 32. So this is just saying that when we convert the tensor, it should be of this data type. And let's also import that one from torch. So we can import that one also, like that. Okay. The other thing is, let's also convert the target, okay, into a tensor. So, just like that. We say this one is d type, also float 32. Okay, so this looks good. If we run, okay, now we shall have our feature set as a tensor. If we look at this, you see we have a tensor. Even our target is now as a tensor. Okay, tensor, like that. All right, so the next thing we want to do is we want to convert this into one single we want to convert this into a vector, into a column vector, and we can do that by adding a dot view, and this is one, like that. Okay, so if we look at y, yeah, now this is better. Okay, now let's go ahead and do one other thing that is really, really important. It is to split our data set into training and test sets, because when we train a machine learning model, we want some test data set to see its performance. Okay. To do that, we shall use train test split from sklearn. So let's just import that one. Let's come here and we say from sklearn dot to it's found in model selection import train test split. Okay, now if we can come here, we shall have x train, and then we shall have y train, okay, rather x test, and then we shall have y train and y test being equal to train test split. Okay, and we can have here x, we can pass in x and y. So in train test split, we actually have to pass in two particular things. Okay, one is the array, and then the arrays. So we have x and y, and then we also want to pass in the test size. Okay, so the test size is basically a fraction of the data set that we want to use for testing. So we can set it to 20% by adding in a 0.2. Okay, like that. That is all that we need to get started. Okay. Now, let's go ahead and do one another thing. Here we want to create a data set. This is a concept that I have discussed earlier on. I have a video on how to create PyTorch datasets. PyTorch has a way of optimizing training by loading the data in a particular way. It's called batches, okay, into the model. This is because sometimes when we are dealing with very huge data sets, passing in the data at once is probably not optimal for several reasons that we shall keep discussing. So PyTorch has a way of handling cases like that. So let's set up our train data as tensor dataset and we pass in xtrain and ytrain. Also, let's set the test data to be tensor dataset and we pass in xtest and ytest. Now, if you are seeing these squiggling things, it's because we haven't imported tensor dataset. So we shall import it, but before we import it, let's also uh, add some loaders. So these guys will be responsible for loading data into our model. So let's say data train loader is equals to data loader. Also, data loader is a class in PyTorch that we use for creating data loaders. Okay, so we shall have train data and we can set the batch size. So the batch size is how many samples will be passed at a time, and we can set maybe to 16. Okay, and maybe the other parameter we want to check out is shuffle. Okay, we can set shuffle to true. All right, so the other thing is we want to create a data loader for testing data. So we shall set test loader is equals to data loader, and we can have test data, and then we can set the batch size as, maybe let's also have this one as 16, and then shuffle also we set this one to true. So let's go up and we import tensor dataset and train loader. Okay, so I'm just doing this so that we can keep organized. Otherwise you could have imported all these things like at once. So we can do from torch dot utils dot data import data loader. Also we can import tensor dataset. Okay, like that. So before we continue, let's also just import the other things that we may need at once so that we don't have to keep coming back. The other thing that we need to import is from torch.nn. We want to import the mean square error loss function. So this one will be the one to help calculate the loss, and as we shared earlier on, the loss in this context is the difference between the predicted values of the model and the true values. So the total loss, which is usually called the cost, okay, is the one that we differentiate and get the amount to add on the weights. Okay, so I have a particular blog, okay, which I'll link also in description so that you can go and read more about losses and cost functions. Okay, so we want also to import sequential, and sequential is the class that we shall just use to set up our linear models, to stack up our linear models or our linear units, okay, into a deep neural network. Okay, so I think this is all. Maybe one other thing we can say from torch dot optim uh, we import maybe we import Adam. Okay, now Adam is an optimizing function that will just help us find the particular amounts to add on the weights to find the best values, the best parameters. Okay, so let's just calm down and then use all that stuff that we have imported. So we shall create our model as sequential. Okay, and then let's stack these. So we shall have a linear unit, and the number of input features here in this case is 13. If you look at our dataset, I'll just say dataset.shape. We have 14 features. One of them is our target, so that's why I'm passing in 13. Okay, now the out features is so we are stacking up neural network. So the out features, maybe I can set 80, okay, to get us started. And I see linear having a squiggle. I think we didn't import it, so let's just come up here and we import linear also. So we can import linear from the other, from PyTorch. Okay, so let's just do that. So we shall do from torch.nn right here. Let's import linear. Okay, just like that, and we make sure we run so that it is updated in memory, and then we can add here the ReLU. Okay, so ReLU right here. Okay, let's do this several more times. Okay, so that, okay, here we shall have only, let's just have only 3 layers for now. I see ReLU also. I guess we didn't import ReLU, so I think it's also somewhere here, so let's do that. ReLU. Okay, so let's come here and modify these copies that we've made. So the first layer is taking in 13 and outputs 80. It means that the next layer will take in 80 and can output, we can use maybe 50. Okay, and then this layer, the third layer, can take in 50 and maybe output 30. So let's just have one other last layer. Maybe this other layer can take in 30 and output say 1. Okay, okay, maybe to just be better, maybe let's let this one output 10. Okay, and then we have one last one that outputs from 10 to 1. Now here's the thing, you may be wondering how many layers should we have, or what are the right number of neurons in a layer. Here's the thing, uh, what is the best number of features for outputting, like how we have in these inner layers. Here's the thing, there is usually not one thing to always go with. So these are things that you can experiment with and you see which one is best, and there is some standard ways of experimenting that we shall be covering in future, so just keep updated. uh, all right, so let's just now that we have our neural network setup, maybe one thing is we don't need a ReLU at the last layer because this one is the output layer, so let's just remove that. Okay, now that we have our model set up, we need to set up also another thing, which is the criteria. So they like to just use criterion like this, and this is the method with which we shall be calculating the loss and cost. So loss is for the difference for one sample, okay, the difference between the predicted and the true for one sample. Then for all samples it becomes, for all samples in a training phase, it becomes the cost. Okay, so let's just set that one, and let's also set the optimizer to be Adam that we imported. We imported Adam up there, and it takes in the model parameters. That these are the parameters that the model of the model, W and B, and it takes in the learning rate. So for now we can just have 0.01. The learning rate also is one of those parameters that they call hyperparameters. There is not one optimum value to always go with, so you just have to experiment and you find which learning rate works best for you. The learning rate actually is what they use to also update the weights. So at the point of updating the weights, we shall be having W, maybe if the first weight, okay, was W0, the new weight W1 will actually be equal to W0, okay, plus the derivative of the cost function, okay, with respect to W times the learning rate. So this is actually how the model parameters are updated. So it means that maybe for the third one it will be W1, okay, plus the derivative of the new loss, okay, times the learning rate, like that. So the learning rate is one of those parameters that are called hyperparameters, because you can't, there is not one agreed on value, but you just keep experimenting. Now let's go ahead and set some other things like the epochs. Epochs refer to the number of times we want to train our model, and then we can set up our train loop. So our train loop here, we shall say for each, for epoch in the range of epochs, okay, we want to train the model.train, and then we set our total loss is 0. Here is the thing, we want to set our total loss as 0 because we shall be accumulating the losses after each iteration, okay, after each epoch. And so at the end of the day we want to use the total loss, the derivative of the total loss we want to use the loss to understand how our model has been learning rather. So let's just go ahead and and say for each batch, remember that we set up our train loader to be passing in 16 items at a time. So for each batch, okay, we want to, for each batch of 16 values, we want to pick out X, and then we want to pick out Y, the true values, okay, in that train loader. And then the next thing we want to do is we want to set optimizer dot 0 grad. I think it's 0 grad, like this. Yes. So here's the thing, because PyTorch, the way PyTorch works is that it keeps differentiating the cost function and it keeps accumulating the derivatives. So we want to, when we are training a new batch, we want to first reset the derivatives, so we can make a prediction now model by using model and then batch X. Okay, so here we predict X, we get our predictions, and then we use our predictions to get the loss, okay, So we can say loss is equals to criterion, and the criterion here we are getting the mean square error between the predictions and the true values. Okay, like that. All right, so after getting the loss, we want to get the derivative. So we can get the derivative by doing loss dot backward. All right, and finally we want to optimize. We want to update the parameters. So we can update the parameters w and b by saying optimizer dot step. Finally, we can save our loss. We shall be using this one in the visualization phase. So we shall say total loss is equal to, we update it with the new loss. Now we do loss.item because we just want to pick out only the value. The calculated loss is actually a tensor with one item. Okay, so when we do that item, we manage to get out that value. All right. Now, just for tracking, logging our training phase, what we want is to print out the loss at each epoch, and we can say if rather maybe let's print out per every 20 epochs. So we shall say if epoch, okay, is divisible by 20. Okay, so here we're just saying that if we have for every 20 epochs, okay, let's just print maybe let's print say epoch, and let's print that epoch, okay, and then we also we show out of how many, okay, and then we print out the loss. So let's supposed to put it here, loss. Now the loss, it will be the total loss at this point, okay, and here is the total loss. We to get the loss for this particular iteration, we can say out of the number of items in the train loader, so every 16. Okay, so if we run this, we can see the loss begins from 9, and then it goes to 5, and then it goes to 4, 3, and it goes to 5 again, okay, and then it goes to 2, then 3, 6, 2, 1. Okay, I think it stops at 1.9. All right, so we can visualize this by using Plotly. So I'll import pandas because Plotly usually takes in a data frame, and then I'll also import plotly.express rather as px, and then we can set the model to evaluation mode, and then we can say with nograd, it's actually with torch dot nograd. Nograd can actually be imported from PyTorch, so let's just find where we are importing things. Maybe let's move even these guys to where we are importing things. So I'll cut them out and then I move them here. Okay, let's also say from torch import nograd, and we can come and say with nograd, like that. We can get the predicted values of the test set by doing model, and then we pass in the x test, then we can convert the result to numpy. Okay, then we can create a Preds dictionary, a Preds data frame by doing preds.df is equals to pd dot data frame. Okay, and then in this data frame we just want to have the actual and the predicted values. Okay, so let's just say this data is equals to the actual, and I don't want to waste your time with this part, so I'll just write it out. We have created probably very many data frames before. And we can have the predicted. Alright, now we can go ahead and plot. Let's create a plotly figure. Okay, we can say fig is equals to express plotly express dot scatter, and then we can pass in the data frame, okay, as the preds.df. We can also pass in a few other things like x and y. So x in this case can be the actual, and then y can be the predicted. We can also pass in the title if we want. Okay, maybe actual versus predicted. And then we can also pass in, maybe let's get a trend line. This one will help us to evaluate our model, and we set this one to OLS like this. Alright, if we do fig.show, then we shall see our graph. Okay, yeah, so this is our graph. If looking at our graph, I think our model is doing quite well. Okay, if we come to the trend line, we can see that our model is showing we have an R square of 80, about 84%. Okay, 0.83. The optimum is 1. Also, if converted to a percentage, is like 100. Okay, so our model is doing well so far, and I would like to stop like at this point, and then in future we shall evaluate some more ways to uh, understand how our model is working. Okay, but I would just like to thank you if you've reached at this point. Okay, just keep up following. I have a whole roadmap that I am shuttering down. Link also will be in the description. If you've reached at this point, it's a show of your motivation, and I'd like to thank you again, and bye for now.